Okay, here we go. Cool. So yeah, so we're clear. If you want to step out, take a break, that's fine. If you don't, awesome. Let's start with talking about some big topics. I'll put in a little poll here. I haven't really used the poll Slack bot a lot, so I'm kind of interested. Nice. Oh, that worked beautifully. Okay, so I just put a poll into Slack, so you can see. I'll share my screen now. Cool. So I just put a poll into Slack. So please go ahead and vote on what you would like to spend the next 20 minutes or so focusing on. This, I'd say, is kind of like a high-level overview of what we've done so far with Ruby. We can also talk about SQL, but I think it's probably too new for you guys to really have deep questions on that. But if I'm wrong, well, just tell me I'm wrong. A lot of stuff on inheritance and advanced object-oriented programming. Yeah, that's kind of what I expected based on talking with you guys. And so let's talk about that a little bit on defining and instantiating classes. Okay. Okay, cool. Let's talk briefly about classes and then move on to inheritance. I'm gonna navigate into a separate directory here. Okay. Alrighty. Actually, I need to do it in here, don't I? All right, so this is going to be classes.rb. Sure. All right, so we want to define a class. How do we define a class? Well, we write class, then we have the name of our class. Someone give me a thing to make a class of. Just shout it out.
Pokemon.
Pokemon, wonderful. Okay, so we have a Pokemon Ruby class. Excellent. How do we create a new Pokemon? Well, we say p equals Pokemon.new. And that creates a new Pokemon object. That's actually all you need to do. If we go into pry and I require that file, okay, that was successful. Is Pokemon a thing? Yes, it is. Pokemon exists. Does P exist? I don't know if I created anything. Okay. P equals Pokemon.new. There we go. I literally, like, I don't need to write anything other than these two lines in order to be able to instantiate a class. Okay. So what if I want my class to have some properties? Well, that's not so hard. Or the instance, let's say. Those get set in the initialize method. The initialize method defines the initial values of every property of my instance. So if Pokemon has a name, and a Pokemon number, I can set those in initialize. Okay, so if I say p equals Pokemon.new, it creates a Pokemon whose instance variable name is equal to Bulbasaur and whose instance variable of NPN is equal to 1. Where did I find those things? In the initialize method, where I set the initial values of those properties. Okay, but what if I want to be able to customize it? Well, fortunately, the initialize method can take arguments. So I can pass in name and NPN. And these will get handed to the initialize method by .new. Now, if I create a new Pokemon, it's expecting 2 arguments. It's expecting a name and a number. I probably shouldn't have written over P like that. Could I zoom in a little? Yes. Let me do that. How's that? Is good? So unfortunately, when I'm screen sharing, I can't really see your screens super well. I can only see like 2 or 3 of you at a time. So if you can, yeah, Slack messages are good. Zach, I was a little slow on the uptake for that. But also just feel free to jump in and come off mic, or come on mic, as it were. Make that bigger too. Okay, cool. Questions so far? Let's take questions. We're reviewing. No? No questions? Really?
Hey Matt, so the what you call it? It's called the sigil, right? What's before the name and NPN? The symbol.
Oh, I just call it an @ I don't know what that's. I don't know what.
Okay, so that makes it into an instance variable when you
Yes.
have that symbol.
That's how you define an instance variable.
Okay.
Or, yeah, I would say every instance variable starts with a single @. Okay, I mean, if you guys don't have any more questions, that's cool. But 3 people wrote that they wanted to see defining and instantiating classes again. So I want to make sure that I'm addressing that. Okay. Cool. Pokemon is great, but it doesn't leave us a lot of room for inheritance. So let's define some new classes. let's use the ones from this morning's diagnostic.
I was gonna say that shapes
Yeah.
polygon.
Yeah, shape or polygon or whatever. Def initialize x, y, and num sides and color, I believe. Is that right? I think so. Trouble keeping it all straight. Something like that. Okay. If I want to have these things be instance variables, I can define an instance variable x. Oh, no, don't autocomplete. God, screw you, Adam. No. Okay, so I can have instance variable x, instance variable y, instance variable num sides, instance variable color. Okay. Nice, nice. Okay, I can now initialize a shape if I want. All right, so I'm going to define some shape, and it's at 4, 4, has 5 sides, and its color is red, bright fire engine red. Okay, so I just created this shape object. It has those properties that I defined when I called .new. I instantiated it. We can't say much about this shape other than that it's a shape that has 5 sides. In the example, you were also asked to define an area method that returned nil. Now, I was asked earlier, why would you do that? I mean, the area is obviously not nil, and on top of that, you know, it's being overridden by all of the child classes, at least all the ones that we defined. I would say it's not necessarily being overridden by every child class, just all the ones that we looked at. It might be possible for us to define a shape that is not a standard shape, but is, say it's an S curve, right? And an S curve, I mean, a triangle, you can define an equation to represent what that area is, but that might not be possible for an S curve. And maybe initialize has some other properties, blah, blah, blah. So if we have that, we might not necessarily have an area function that we can use to calculate the area, in which case we would just leave it nil. And it still makes sense for that to be the default because there could be other shapes for which we can't necessarily calculate the area with the information we have. Okay, let's get specific. We want to have a rectangle. What does a rectangle have? Well, a rectangle has everything else that a shape has. So it has X. No. It has Y. It has num sides. It has color. But it also has base and height, or length and width, or whatever you want to call them. 2 dimensions. And based on those properties, it has a method called area, which returns length times width. So I'm going to set it so all these get initialized. X, Y. Okay, so we've defined this rectangle class. When we instantiate a rectangle, we pass it some values. And yeah, and so we can set properties on a rectangle when we create it. So if I go to pry, I load in my relative, I can say R equals rectangle.new, and I can give it an X and a Y. Number of sides is 4. Color is that was dumb. Green, and length is 5 and width is 6. Okay, and I can create an object with all of those properties. Okay, now it actually doesn't make sense for us to define num sides here because we know that by default there are 4 sides to a rectangle. So we don't need to pass that in as an argument. We can just give X, Y, color, length, and width. Fine. So this is great. Let's do another one. Let's create a square. So we'll create a square. Give it an initialize method. And a square is going to take an X and a Y. And it's going to take, well, it's not going to take a number of sides because we know a square is going to be 4 sides. And we know that it doesn't need a length and a width, it just needs a side length. So color, side length, because both sides are the same in a square. Okay, so X equals X, Y equals Y. Num sides equals 4. Color equals color. Oops. Sorry, brain fart. Oh, except we didn't define length and width, right? I mean, it could have had those as arguments over here, but instead we've just decided that it's going to be side length since both sides in a square are going to have the same dimension. So we'll save that. Oh, and we want to have an area function too. And we can use the same area formula that we had last time because it's fairly easy. Right? And we can create a square. Square length and width. Okay, so if I quit, open pry. So I can create a new rectangle. Oh, I don't need to specify 4 sides anymore. I can say S equals square.new. And a new square takes X, Y, color, side length. So X is going to be 3, 5. Color is going to be black. And side length is going to be 2. It's a little black square. Okay, so great. We're done. Yeah, really, we're done. We've created all the stuff. It's kind of a lot of code though, right? A lot of it's kind of similar. I think that we can make this better using inheritance. Okay. So all of this, right, is the same as all of that was, plus length and width. These four are just literally lifted from right over there. I would like to be able to use the initialize method that was already defined on shape. How can I do that? Can anyone tell me how I can do that?
Use super.
Super. What does super do, Zach?
I believe it will basically call upon the initialize method from the, I don't know if I'm using the right word, but from the parent or from,
Yep, that's right. Parent class.
yeah. So the first method to run will be the initialize method within that class, that rectangle class, and then it will look to the parent, I believe.
Yeah, that's right. So initialize, this is just a method, right? It's a method that's being defined inside the class. Similarly, this is also just a method that's been defined inside the shape class. When we call super, we just take advantage of a method that we've already written. In this case, we set x to x, y to y, num sides to 4, and color to color. So I'm just making that 4 rather than num sides. But these are two new properties that didn't exist in shape. So we set those here. All right, so that's a little bit shorter. And on top of that, area is about the same. That is relying entirely on our new properties, length and width. Okay. Cool. So we can do the same thing with square, right? We could inherit from shape. And I'll take that. So now square is a kind of shape. And we say that it is XY4 color, right? So it sets all the same properties the shape does, but it also defines a length and a width, which are both equal to side length. And we also define an area method because, as we can see, area method just returns nil for a shape. I'm going to make that a little smaller so that you guys can see all of it. Or almost all of it. Is that better? Can everyone see? Okay. So now square is a kind of shape. It inherits from shape. It's a subset. Every square is a shape. Okay. And so we can call super. Excuse me. Super, by the way, doesn't just work for initialize. It's true for any method. The reason it's called super is that it refers to the super class. Super class is the class that your class inherits from. So it's the super class's version of this method, which can be initialized or actually anything else. Okay, this is great. Are we done? Well, we can be, but it could be even better, I think, right? Because this is kind of the same between these two classes. And this area method is exactly the same. Wouldn't it be nice if we could leverage that somehow? Well, as it turns out, a square is a kind of rectangle. So maybe we can inherit from a rectangle instead of just a shape. If we do that, meaning of super changes. We can't keep that exactly the same anymore because instead of referring back to shape, Now this refers back to a rectangle's initialized method. So we can replace that as super, and the initialized method for a rectangle takes x, y, color, length, and width. So pass along x, y, color, and then side length is going to be equal to both length and width. Cool. That'll call the initialize method on rectangle and do all the stuff that's specified here. And we don't need to define area here anymore because area is already defined in rectangle. So we can just delete that. Now our classes are smaller and they're less duplicative. On top of that, if we wanted to change something here, we could affect all three of these classes at the same time. For instance, suppose I come up with a new property.
Hey Matt, just interrupting. We're a little behind for outcomes. Or we have a panel waiting.
I'm letting you go. I'm done.
Do you want to assign homework after?
Yeah, I'll send it out. It's just completing a tutorial, so there's not much to say about it.
Okay, cool. Sorry.